Welcome to Amateur Radio's Reflector Magazine by the East Coast Reflector. Volume 24 of the Reflector Magazine, January 2026. Articles featured in this volume: Dick's Corner, the Antenna Farm, a short HF antenna, RF generator to AF generator, SM0VPO, how APRS works, KC2NJV, 3D printed HF antenna, celebrity Callsign, Gary Goldwater, world radio history, radio questions answered, and how the sun grounded 6,000 planes, KE8VKY. You'll also find information on nets, user-submitted pictures, Zoom events, system and connection information, silent keys, and more. Table of contents. What's in this article, Dick's Corner? In this article, Dick shares timely updates, reminders, and a few notes to help keep the East Coast Reflector running smoothly. Amateur of the Year recognition, holiday event recap, net staffing update, volunteer opportunities, presentation outlook, EchoLink operating reminders, learning and mentoring invitation. A new year with the East Coast Reflector. Happy New Year to the entire East Coast Reflector family. As we roll into another exciting year of amateur radio, we'd like to take a moment to recognize some outstanding contributions, share a few announcements, and welcome new faces to the Reflector. ECR Amateur of the Year 2025. We are proud to announce Joe KO4FRR as the ECR Amateur of the Year for 2025. Joe may not be heard on the air as often as some, but make no mistake, his presence is felt everywhere behind the scenes. From technical work to daily operations, Joe is constantly keeping things running smoothly. Between Joe and Vicky, the shop stays busy and productive, ensuring the ECR continues to operate at the high standard our members expect. Congratulations, Joe, and thank you for everything you do for the ECR community. WB2JPQKO4FRRW2BLT, a special ECR Christmas. Thanks to a very special visit from Santa Claus, the ECR Christmas was a memorable one. We had several boys, girls, and adults asking Santa for Christmas presents and even for peace on Earth. Thank you to everyone who helped make Santa's visit a success. Morning Brew Net Update. We are happy to welcome Andy, W2AJR, as our newest Morning Brew Net controller. Andy will be joining the net in mid-January, and we're excited to have him on board. Please give Andy a warm ECR welcome when you hear him on the air. Volunteers needed backup loggers. The ECR is currently looking for backup loggers. If you think you can type approximately 100 Callsigns into our log sheets over a 2-hour period, Vicky would love to hear from you. This role is vital to keeping our nets organized and running smoothly, and it's a great way to contribute to the Reflector. Presentations. Our presentations continue to be an important part of the ECR experience. Keep an eye on upcoming announcements for more details and opportunities to participate. Be courteous. We love our EchoLink users and the unique access EchoLink provides to our system. With that being said, I must remind everyone that an EchoLink station can only get in when there is not a carrier on the frequency. Please remember to leave long breaks between transmissions. A reminder for EchoLink users. Over the last year, we've seen an increase in system timeouts, most of which are tied to EchoLink users. We kindly ask EchoLink operators to be especially mindful of their PTT use, ensuring transmissions are intentional and that the PTT is off when finished. A little extra awareness goes a long way in keeping the system healthy, reliable, and enjoyable for everyone. With the continued cooperation of our EchoLink users, we can ensure this feature remains a positive part of the ECR for years to come. New hams, you're invited. To all of our newly licensed hams and Season 2, we encourage you to stop by our Ask and Elmer Zoom room. These sessions are held on the first and third Thursday nights at 8 p.m. and are a great place to ask questions, learn, and connect with experienced operators. Here's to another fantastic year on the East Coast Reflector. Thank you to everyone who makes this community what it is, on the air and behind the scenes. 73. Dick, WB2JPQ. Connecting to ECR is simple, and there is no membership or club to join. Everyone is welcome. There are no fees or permissions. Just connect. If you have audio or connection issues, we're here to help. Simply free. The way that air was meant to be. Connecting to the ECR with the SharkRF via AllStar. where to find your local node password. The Reflector Magazine is available on YouTube. Watch along on the pages and listen to the voiceover as it reads to you. It's great for blind, visually impaired, people who'd prefer to listen to the audio, or people who need something to listen to while they mow the lawn. If you know of someone who would benefit, pass it along. The ECR can use your help. We need net controllers and loggers. We also need a Zoom greeter and a podcaster for YouTube. Reflector etiquette. Here's a list of common courtesies for the Reflector.
The Antenna Farm, Part 38, a short HF vertical antenna. In this article, in this installment of the Antenna Farm, Charles KC6 UFM shows how to build a radically short HF vertical antenna that proves you don't need a lot of space or money to get on the air across multiple bands. How a less than 6-foot vertical can operate from 160 meters through 6 meters. Why this antenna is ideal for limited space and HOA-restricted locations. The pros and cons of extreme compromise antenna designs. What materials and tools are needed for a low-cost DIY build. How loading coils, counterpoise wires, and grounding affect performance. Choosing between 4-to-1 and 9-to-1 anuns for real-world installations. Practical mounting and installation tips for reliable tuning. What kind of performance to realistically expect, and where this antenna shines. A practical, honest look at a compact antenna that trades size for versatility. Perfect for operators who just want to get on HF and make contacts. A short HF vertical. Part 38. Hello ECR family, and welcome to the Antenna Farm. This is your friendly antenna farmer Charles, KC6 UFM. As always with the Antenna Farm topics, I welcome any and all feedback from you, the reader. I'm almost always monitoring the East Coast Reflector, and my email is on my QRZ page. I am also on the ECR for almost every Tuesday night TechNet, so this would be a great place to ask questions, too. Feel free to reach out to me with any comments or questions. But there's a new, and in my opinion, great place to ask questions about the Antenna Farm or antenna systems in general. Join me, along with other Elmers, in the East Coast Reflector Zoom room on the first and third Thursdays of each month at 8 p.m. Eastern for the Ask an Elmer/Be an Elmer event. This is a chance for all hams, especially those new to the hobby, to ask questions that may be too involved to get detailed answers from the TechNet. I look forward to you joining us and asking your questions. The Antenna Farm. Today at the Antenna Farm, I'm going to show you an easy-to-build, very small and functional vertical antenna for 160 meters through 6M operations. When talking about the HF bands, there are a few things to keep in mind. First, the practical definition HF is a little fuzzy. Strictly speaking, in terms of physics and engineering, the ham radio HF bands are 80 meters through 10 meters. In a practical sense, and in most cases we hams include the 160 meters and 6 meters bands with the other HF bands. For our purposes here, we're going to use that practical definition of 160 meters through 6 meters. Second, we need to think about the HF privileges of the active ham radio license classes. General and extra class licensees have, of course, access to the full 160 meters to 6 meters spread. Technicians, who, by the way, make up just over half of all U.S. hams, have full access to the 6 meters band, plus 28 megahertz to 28.5 megahertz on 10 meters, and a few small CW-only segments in the 80 meters, 40 meters, and 15 meters bands. Note that some of these allocations have power limitations. This means that this antenna will be of use to all classes of U.S. hams. Third, while VHF and UHF bands are line of sight, this is not strictly true, and some interesting communications can be made far beyond line of sight. The HF bands are subject to very long-distance propagation modes of several types. In other words, on V/UHF, a long-distance contact of 100 miles is something to get excited about, but HF can and does regularly allow worldwide communications. A better name for this antenna might have been a radically shortened HF vertical. Why do I say that? Because the antenna is less than 6 feet tall. No, that's not a typo and you read it right. I said 6 feet. But before we get into materials and how to build this antenna, we need to look at the pros and cons of the design. This antenna is not for serious DX work. We've all heard of compromised antennas. And this one is about as compromised as an antenna can get. This antenna is, as mentioned above, only 6 feet tall and is therefore much shorter than a half, or even quarter, wavelength on all bands except 6 meters and 10 meters. The angle of radiation is quite high, on the order of 50 degrees above the horizon. This means that the main part of the radiated signal is far from the desired point for serious DX work. With that said, this antenna does very well for contacts with stations that are closer to your location, out to around 500 miles or so. You will need an antenna tuner for this antenna. The odds are that the tuner built into your radio won't be able to get a good match, so an external tuner will be needed. My LDGA 600 Pro II works very well, though it can be a little dicey on 160 meters. This need is because of the extreme shortening of the antenna. A good counterpoise and grounding system will help with this. This antenna is great for extremely limited space use and to keep the local HOA happy. Again, this antenna is less than 6 feet long and it's less than 2 inches in diameter. It's easy to hide and very unobtrusive in appearance. It can even be mounted on a balcony and be almost invisible. This antenna is cheap and easy to build. Even if you buy everything new, the cost will be less than about $30, not including the unknown, at the big box home improvement stores. The most expensive part is the matching transformer, a NUN type see below, and that will be less than $100 bought brand new and ready to use out of the box. You can, however, build the unknown for about $20 and a half-hour work. Let's look at the materials you'll need to build this antenna. PVC pipe, 1 1/4 inch trade size. While the antenna will only use about 66 inch of this pipe, I suggest you get a 7-foot length to leave some room to mount the antenna. See later for mounting details. Wire. You'll need about 50 feet of number 16 AWG insulated wire. I'll make 2 suggestions here. Stranded wire is easier to work with, and THHN wire will hold up well to the weather. With that all said, just about any insulated wire between 12 and 18 gauge will work, so check your junk pile. Zip ties, long enough to go around the PVC pipe, and preferably UV resistant. Unknown. This antenna was designed with 4 to 1 unknown in mind, but in practice, a 9 to 1 often works better depending on quality of your grounding and counterpoise system. A perfect system will work great with a 4 to 1, but a typical real-world system will work better with a 9 to 1. See below for more information. Mounting hardware. This will vary depending on your particular needs, and we'll look at more details below. Covering. This is purely optional, but will both extend the life of the antenna and make the antenna look better. You can just wrap the entire antenna in some duct tape, available in many colors, even various camouflage prints, or other kinds of tape. One option that I have used many times is to get some of the large heat shrink tubing used to put around lithium-ion battery packs that's large enough to slip over the antenna and then shrink it in place. This tubing is cheap and comes in a number of colors. Here are the tools you'll need to build the antenna. Hand drill. Use the drill holes to secure the wire to the PVC pipe. You'll need a bit that will fit the diameter of the wire you select. Saw to cut the PVC pipe as needed. I usually use a hack saw, but just about anything will work. Another option is an actual PVC pipe cutter. Tape to temporarily secure the wire to the PVC pipe during construction. Duct tape is a good choice as it's strong, secure, and still easy to remove. Tape measure to measure the PVC pipe and locations for various antenna segments. Marking pen to mark locations as needed. A sharper marker works great. Now, let's get to the nitty-gritty of the antenna. Image. This article continued on page 90. There's a link in the description if you'd like to skip to there now.
Check out the ECR nets. The Tech Net Tuesdays at 8. The Trivia Net on Saturdays at 11 p.m. Be on the Open Mic Net Wednesdays at 8. Join us in Zoom for the Youth Net Fridays at 8. The 20-meter net Thursday mornings at 10. The 40-meter net Saturdays at 9 a.m. The morning brew weekdays from 7 to 9 a.m.
In this article, Harry Lythall, SM0VPO, explains a minimal component AF converter circuit is explained. Key points. Using an RF generator with AM as a quick audio source. Minimal component AF converter circuit explained. Construction tips and non-critical parts values. Step-by-step instructions for setup and usage. Adjusting audio levels and modulation for best results. Safety notes and practical considerations. Suggestions for checking existing RF generator outputs. Encouragement to experiment and provide feedback. Introduction. I've already made several audio frequency generators, but to be honest, it is not worth much effort for me to make one. I have used an EPRM AF generator with a sinusoidal data table and a resistive D/a converter. More recently, I built a retro Weinbridge audio generator using a thermistor for control. But today you can download an AF generator application for your mobile telephone, even an audio spectrum analyzer. If you do not want to muck about or risk your $650 mobile telephone on the workbench, and you already have an RF generator with amplitude modulation M, then you also have an AF generator handy. I am lucky to have a 6,000-pound RF generator. It can deliver up to 1 watt of RF. Internal modulation ranges from 0.1 Hz to 250 kHz. I can use this as an all-singing, all-dancing audio generator using only 5 components on a small board. If you accidentally stuff a few volts of DC into it, then you will not damage anything, at least nothing expensive. Maybe just a diode. Concept. If your RF signal has amplitude modulation, then all you need to do is to use a simple diode detector to recover the audio. Then you have got an audio source. If you have no AF generator and need one now, then you can cobble one together within just 5 minutes. All you need is 2 resistors, 1 germanium diode, 1 electrolytic capacitor, and 1 small ceramic capacitor. The 47 picofarads capacitor can also be missed if you use a coaxial cable from the board to the project. This will probably be the simplest, easiest, and most useful project you have ever built. It uses no transistors, integrated circuits, or any active device. It needs absolutely no power supply to run it. Circuit diagram and construction. The circuit diagram is really easy. It is basically an untuned crystal radio receiver, but it is complicated only by the addition of an electrolytic capacitor to block DC from the output terminal. This is one of those projects that are best built as a rat's nest. Complete circuit of the RF generator to AF generator converter card. I didn't bother to make a printed circuit board PCB. I didn't think that the project warranted a board. Instead, I cut a bit of unetched copper-clad PCB, about 4 cm x 5 cm. To this, I superglued 3 little PCB offcuts, about 5 mm x 7 mm. The actual sizes are not all critical. You can read the dimensions as inches and get a much bigger board. You could even build it in a nice posh box, but the construction method will have absolutely no effect whatsoever on the final project. Here is the finished project. Completed RF generator to AF generator converter card. Note that none of the components are critical. You can vary the values by about plus or minus 50% without any noticeable change in performance. The 4.7 K omega resistor should really have been 10 K omega in the days of the ubiquitous 10K probe. The 47 ohms resistor is just a load for the RF generator. My RF generator shuts down if the reflected power at the output exceeds about 100 milliwatts. The 47 picofarads is to smooth the recovered AF from the received audio. I chose such a small value so that I can use the 500 kHz modulating frequency. If you're only interested in 20 Hz to 20 kHz, then 500 picofarads or 1 nanofarad is okay, but I sometimes need frequencies of up to 250 kHz. The 2.2 microfarads capacitor can be as low as 100 nanofarads. I use 2.2 microfarads because I find it useful to have really low frequencies like 1 Hz or less. The input plug is not mounted on the board. I just cannibalized an old N-type to something else cable and soldered the cable directly on the project board, leaving the N-type connector on the other end of the cable. The cable can be as long or as short as you want it to be. The diode can be an old germanium diode, but a 1N914, 1N4148 will give excellent results if the RF level from the generator is kept high. If you want really low audio levels, less than 10 millivolts, then use a zero-bias Schottky diode. Using the RF to AF generator converter. To use the RF generator to AF generator converter, plug the RF input to the RF output. Set the RF generator to the highest RF output available. Set the frequency to something high. I use about 100 MHz, but it can be anything from 25 MHz to 1 GHz. Set the modulation level to the highest you can get, not more than about 80%. Set the generator modulation source to internal and sine, if these options are available. Select the modulating frequency to the audio frequency you want. Now you can connect an oscilloscope to the two output wires and view the audio level received from your RF signal generator. I use two croc alligator test leads to couple the audio to my circuits on the bench, but you can still use an oscilloscope probe if you need a BNC input to the circuit that needs audio input. If you see low-level RF on the output waveform, then you can increase the 47 picofarads or increase the generator radio frequency. Adjust the audio level by either adjusting the RF generator modulation depth or the RF level. Either will work, but you get much better linearity if you adjust the modulation depth. This is because the signal diode in this project has a forward bias level, which means that it needs typically 1 volt RMS before the diode will conduct anything and still decode it. At low RF levels, it can also become nonlinear. It is better to lower the modulation depth in this event. So that is it. Could it be more simple? That was a rhetorical question. I once lost my company ID card, and so I posted a few flyers on posts in the neighborhood reading, "Have you seen my ID card?" Several people rang me to tell me that they had not seen the card. So many helpful people around. Conclusion. In this article, I have shown you how to get an audio signal from your RF signal generator in a really simple and cheap way. You can build it in a mini aluminum box that plugs directly on the RF signal generator, but I think that this is a bit dangerous for mechanical reasons. I am 72 years old and a bit clumsy these days. One small suggestion, if you have a decent RF signal generator, just check the rear panel. It may have an audio output socket marked mod out or something similar. If this is the case, then you do not need this circuit. It is worth checking just in case. I hope that this project has given you some food for thought. You can always email me at harry.lythal@sm0vpo.com. You can even use oeieio@hotmail.com or hotmail@sm0vpo.com, as they are both valid email accounts for me, although I would prefer that you visit my message board if you have any questions about this or any other project. I always look forward to receiving feedback, positive or negative. Very best regards from Harry, SM0VPO. Original article can be found at sm0vpo.com. Previous articles by Harry SM0VPO.
Audio check. There are great audio tools on the website at eastcoastreflector.com. There's a Listen Live player for listening anytime, equipped with a visual audio meter. There's a second player with a 2.5-minute delay. This allows you to do your own audio check. To hear what your audio sounds like, load up Listen Live on the website. Pick up your radio, give your call sign, and say this is an audio test. No response necessary. Then wait a minute and listen to the playback. Still stumped? Come into our Zoom room for advice at bit.ly/ECR daily. The ECR helpline. If you're having a difficult time connecting to the ECR or need to make us aware of a problem, call or text our helpline at 746-427-4142. We'll help you the best we can. This is not for bad audio or rude hams. This is for things that need current attention, like someone sleeping on the mic about to time out the system or someone being very aggressive. We appreciate your help. Did you know that we have a gift shop? You can help to support the East Coast Reflector at the gift shop. You can get your call sign, put on an ECR shirt starting at $17.68, coffee mug from $12.60, or a polo from $22.49. Be a contributor. Do you want to help contribute to the magazine? Send in your article, project, story, comment, and suggestions to editor@ecr@gmail.com. You don't have to be a good writer if you have a good story. Everything will be polished and sent to you before it's published. You should know. The East Coast Reflector and its Reflector Magazine is all volunteer run. We charge nothing to use the system and nothing to subscribe to the magazine. The system has hundreds of nodes and repeaters connected at any given time. We incur a lot of expenses to maintain such a large system. If you use the system or enjoy the magazine, please consider helping by contributing to the system by going to eastcoastreflector.com and click on Donate. Your contribution is greatly appreciated. In this article explains how solar activity disrupted modern aircraft and what hams can learn from it. October 2025 Airbus A320 flight incident caused by solar radiation. Single event upsets, SCUs, explained for digital fly-by-wire systems. ILAC module vulnerability and how a single bit flip led to incorrect commands. Fleet action, software updates or hardware replacements for 6000 planes. How solar radiation can affect electronics beyond radio, including data corruption and logic errors. Relevance to amateur radio operators. Monitoring space weather matters for all electronic systems. Links to official sources and further reading. When amateur radio operators think of solar activity, we usually picture HF blackouts, auroral skip, fading signals, or noisy bands. But in late October, the sun proved it can affect more than radio propagation. It can reach directly into the electronics of modern aircraft. After a startling flight incident on an Airbus A320, investigators discovered that energetic particles from space could corrupt flight control computer data. This led Airbus and global regulators to require urgent fixes on about 6,000 A320 family jets, temporarily grounding or restricting one of the most widely used airliners in the world. What happened? On October 30th, 2025, a JetBlue Airbus A320 flying from Cancun to Newark suddenly pitched down without pilot input. The crew recovered the aircraft, diverted to Tampa, and reported several passenger injuries. After investigation, Airbus concluded that solar radiation may have caused a corruption inside a critical flight control module, triggering incorrect control commands. Because the A320 uses a digital fly-by-wire system, meaning flight surfaces respond to computer logic instead of mechanical linkages, even a single corrupted data bit can produce a dangerous response. Airbus issued an urgent bulletin, and aviation authorities ordered operators to update software or replace hardware before flights could continue. The technical issue, single event upsets. A key component in the A320's fly-by-wire system is the ELAC, elevator aileron computer. Certain ELAC units were running a software version found to be more vulnerable to single event upsets, SCUs, bit flips caused by high-energy particles. At cruising altitude, aircraft sit above much of Earth's atmospheric shielding, making them more exposed to space radiation during active solar periods. A single particle striking a sensitive part of a microprocessor or memory chip can flip a 0 to a 1, or vice versa. In most cases, redundancy and error checks catch the problem. But under the affected configuration, the ELAC could accept the corrupted data as valid, leading to an incorrect control command. For radio operators familiar with digital modes, imagine a cosmic noise burst landing exactly on a weak packet, not enough to shut the system down, but enough to alter a critical bit in the wrong direction. The fleet action. On November 28, 2025, Airbus issued a precautionary safety action stating that thousands of A320 family aircraft required one of two fixes. Software rollback to a previously validated and more radiation-resistant version, or hardware replacement for certain ELAC units. Most jets only needed the software change and returned to service within hours. Older aircraft with affected hardware required longer downtime. In total, approximately 6,000 aircraft worldwide were listed as needing correction. Why solar radiation matters. Hams are very familiar with the sun's influence on our bands, but its effects go far beyond RF. High-energy protons and cosmic rays can flip microelectronic bits, SCUs, cause data corruption, trigger resets in digital systems, introduce unpredictable behavior in logic circuits. This incident served as a real-world reminder that the same solar energy that drives our DX conditions can also affect the critical infrastructure we depend on. What it means for amateur radio operators. Space weather affects everything electronic, not just radio. Modern aircraft depend heavily on software, making them vulnerable to rare but serious radiation events. Monitoring solar activity matters across multiple fields: aviation, broadcasting, satellites, GPS, power systems, and radio. As solar cycle 25 continues producing elevated activity, it's more important than ever to understand and monitor the space weather environment that surrounds us.
Connections printable. There are many ways to connect to ECR. For a printable list, go to bit.ly/ECR Connect. There, you will find the information on the many different ways to connect. Got DMR? Connect to the East Coast Reflector using 32.15714. You can find a map of repeaters on eastcoastreflector.com. If you have a repeater that's connected at least 60% of the time, is 10 watts or more, has an outside antenna, and is open for others to connect, then let us know and get on our map. The ECR is on Discord. Join us at ecr.radio/Discord. Social media. The ECR is building up its social media presence. Join our Facebook group so you can enjoy our ham radio content and stay up to date on ECR information, and so you can update us on your ham shack and ask questions. Just like on the air, we don't tolerate trolls. You're free to ask questions troll-free. We keep it an enjoyable place. Check us out also on X, Twitter, Groups.io, YouTube, and most recently Discord. We look forward to you joining us. In this article explains APRS Automatic Packet Reporting System in a simple, ham radio-friendly way. What APRS is and how it sends digital data over radio. How TNCs, digipeaters, and I-gates work to relay messages. The four main types of APRS messages: beacons, bulletins, text messages, and bots. Examples of APRS use: GPS location reporting, weather updates, emergency communication. How different message types serve different purposes. Benefits of APRS for everyday use and emergency preparedness. Links to further reading and technical resources. How APRS works. A simplistic explanation of a complex system. Prologue. I have simplified the concepts contained herein. While factually correct, there are additional aspects that can modify and amplify the information or the way APRS works. It is up to the reader to decide if they want more detailed information. What is APRS? APRS stands for Automatic Packet Reporting System. It is a special way that ham radio operators can send messages and share information using their radios. APRS is a digital communication system based on SBAX.253, a communication protocol. Like all computer languages and protocols, it has grammar, structure, and rules. How does APRS work? APRS sends small bits of computer data through radio waves. Your radio works with a computer or special device called a TNC, terminal node controller, that changes the computer information into radio signals and back again. When you send an APRS message, it goes out on the radio frequency and other APRS stations can receive it. These stations can be other ham radio operators, or they can be special gateway stations that connect to the internet. APRS is delivered in real time, and if your device is not on, you will miss the message. How far a message will travel depends on normal radio signal travel, your radio and antenna, and how you set up your APRS equipment. The path the packet is sent on will decide if the packet stops locally, 1 hop, regionally, 2 hops, or possibly around the world, 3 hops. A hop is a single retransmission of a data packet by a digital repeater, or digipeater. Also important is whether that packet is picked up by an I-gate, which sends radio signals to the internet, or a digipeater, which sends signals between radio and internet. Just remember that many radios, digipeaters, and I-gates may hear the same message and forward that message on, based on how the path is set up. The 4 main types of APRS messages. APRS has four main ways to send information: beacons, bulletins, text messages, and bots. Each one works differently and is used for different purposes. 1. Beacons. Beacons are like automatic announcements that your radio sends out on its own. A beacon can be set to automatically send over the air at fixed times without you having to do anything. Superscript 1, the most common type of beacon, tells other people where you are located. For example, if you have a GPS connected to your APRS radio in your car, it can automatically send out your location every few minutes. Other ham operators can see on their computer or radio screens exactly where you are driving. This is really helpful for emergency workers, people on road trips, or during special events like parades. Beacons can also share other information like the weather at your location, how fast you're traveling, or which direction you are going. Some people set up weather stations that automatically beacon the temperature, wind speed, and rainfall in their area. The same radio may beacon one time a minute or one time an hour. If you are in range and your radio is on, you might get up to 60 beacons an hour. 2. Bulletins are messages that go out to everyone in an area, not just one person. Bulletins are simply messages sent to call signs that start with BLN followed by a number or letter. Any grouping starting with BLN with a maximum of 9 characters is a valid bulletin name. Think of bulletins like announcements on a school loudspeaker. Everyone can hear them. Ham radio clubs often use bulletins to tell people about meetings, emergency situations, or important news. For example, if there is bad weather coming, someone might send a bulletin that says, "Severe storm warning, take shelter now." Everyone with an APRS radio in that area would see this message. Bulletins are sent whenever the author chooses them to go. A rule of thumb is every 20 minutes, but some people send their bulletins every 4 hours. Superscript 1, what's different with bulletins is the ability to turn them off or filter them to only a few types. There are standard bulletins, and the major ones are BLNX, BLNX-NET, and BLNA through BLNZ. In fact, many radios and smartphone apps allow you to adjust mute ringers, vibration, reception, and other aspects of APRS. What you can adjust is unit software dependent. 3. Text messages. Text messages in APRS work a lot like text messages on your phone, but they go through ham radio instead of cell towers. You type in who you want to send the message to and what you want to say. You can send a message to just one person by typing their ham radio call sign, like W1ABCXX, and then your message. The APRS system will try to deliver your message to that person. When they get your message, their radio can automatically send back a receipt to let you know they received it. These messages are great for staying in touch with other ham operators when you cannot talk on voice radio, or when you want to send exact information like addresses or phone numbers that might be hard to understand over voice radio. Text messages are just sent. You cannot block text messages, you just have to ignore them if you don't want them. 4. Bots. Today, we also have mailing lists in APRS, commonly called nets. These are run by a computer program called a bot. Most bots will just take a message and send it out to everyone on their list. I created a special bot that has store and forward abilities too. This means if you miss the message, it can be sent again at a later time. Superscript 1, this happens either when the bot hears that your radio is on the APRS system or at a scheduled time. Bots are different because you can subscribe and unsubscribe. So if you no longer want the text messages, they stop. Superscript 1, you can also, on my program, turn the store and forward feature off or on. Why these different types matter? Each type of APRS message serves a different purpose. Beacons work automatically to share your location and other information. Bulletins send important announcements to everyone in an area. Text messages let you talk privately with one person. Bots create mailing lists where people can join or leave as they want. This variety makes APRS very useful during emergencies. When hurricanes, earthquakes, or other disasters happen, regular phones and internet might not work. But ham radio often still works, and APRS can help emergency workers know where people are and what help they need. APRS is also fun for everyday use. Many ham operators enjoy tracking their friends' travels, sharing weather information, or just trying out this neat technology. Conclusion. APRS makes ham radio more powerful by adding computer smarts to regular radio signals. With its 4 main features, beacons that automatically share information, bulletins that send announcements to everyone, text messages for personal communication, and bots that create smart mailing lists. APRS helps ham radio operators stay connected and share important information quickly and easily. The best part about APRS is that much of it works automatically. Once you set it up, your radio can share information and receive messages without you having to do anything. It is like having a smart radio that knows how to send text messages and share your location all by itself. Whether used for emergency communication or just for fun, APRS shows how creative ham radio operators can be in finding new ways to communicate with each other around the world.
User submitted pictures. Net questions. Here's a list of most of our net questions. Ever wonder how your answer compares or what the results were? Click the question to see the results. There's questions from the Morning Brew, and the Tech Net and the Trivia Net. The ECR has unique log sheets and you're welcome to watch along. You can see where you are on the log, answers to the questions, and even birthdays and more. Go to bit.ly/ECR logs to get access to view all of the net logs. Text or email to get your spot in the log. Our nets can be so busy that people have a difficult time getting in. We want to help everyone get on the air. So we came up with a unique way to get more people on the air. Text your call sign to 716-317-9050. Standard messaging rates apply. You can also email your call sign to text@ecr.radio. This will get you onto the log. This is not for ins and outs. It's to help get people on the air and through the pileups. Our nets.
Barry was born on the first day of 1909, the son of Baron and Jojo, in Phoenix, Arizona. After performing poorly academically as a high school freshman, his parents sent him to Staunton Military Academy in Staunton, Virginia, where he participated in varsity football, basketball, track, and swimming, and was senior class treasurer. He graduated from the academy in 1928 and enrolled at the University of Arizona, but dropped out after only 1 year. After the United States entered the Second World War, Barry received a reserve commission in the United States Army Air Force, the predecessor to today's U.S. Air Force. He trained as a pilot and was assigned to the Ferry Command, a newly formed unit that flew aircraft and supplies to war zones worldwide. He spent most of the war flying between the U.S. and India, via the Azores in North Africa or South America, Nigeria, and Central Africa. Barry also flew what was colloquially called the hump, one of the most dangerous routes for supply planes during the war. The route required aircraft to fly directly over the Himalayas in order to deliver desperately needed supplies to the Republic of China. Following the end of the war, Barry was a leading proponent of creating the United States Air Force Academy, and later served on the Academy's Board of Visitors. The Visitor Center at the Academy is now named in his honor. He remained in the Army Air Reserve after the war, and in 1946, at the rank of colonel, he founded the Arizona Air National Guard. Barry had quite a successful second career, as United States Senator from Arizona, and as the Republican nominee for U.S. President. With those hints, you probably guessed who once held the call sign 6BPI, K3UIG, and K7UGA. Barry Goldwater. That last one is still used as the Central Arizona DX Association Club call. He became a silent key on May 29, 1998, at the age of 89, due to complications from a massive stroke in 1996. Previous celebrity call sign articles.
QSL cards courtesy of hamgallery.com. All of the ECR nets and events are on our calendar at eastcoastreflector.com. Subscribe to the calendar to stay up to date. Elmer Zoom meeting. Everyone is welcome to come in and ask questions or help answer question. The first and third Thursday of each month. On the second Thursday of each month is our ECR virtual town hall meeting. Stop by to ask questions, make suggestions, and learn about the system.
Operator oddities. We lived out in the country, and my nearest neighbor was 15 acres away. One day, he called me frustrated, saying I was interfering with his TV so badly that he couldn't watch his football game. Being a Seahawks fan, it was clearly an important game to him. I assured him I wasn't on the air and hadn't been for hours, but told him I'd come over to check it out. While we were chatting, his TV screen suddenly filled with static, and the audio became completely garbled. I pointed out that it couldn't be me since I was right there. After a while, it stopped. As we continued talking, the issues started up again, and that's when I noticed his fridge compressor had kicked on. I unplugged the fridge, and his TV immediately went back to normal. By Monday, he had a new fridge delivered. Bill. Radio crossword. All of the answers can be found in this issue of the magazine. Ham comics. It wasn't love at first sight, but the mismatch was undeniable. Try a quick little general exam practice. A handful of questions to keep your skills sharp or to help practice to take the test. Birthday call sign word search puzzle. You can add your birthday by going to bit.ly/ECR birthday. And of course, a jigsaw puzzle. You choose a number of pieces and put it together from your device.
The original article is very long. Parts of the article will be split up into 7 pieces over the next issues. The full original article can be found at worldradiohistory.com in the Experimenter's Library Number 3. This is an old article from 1924 and is for educational purposes only. Part 1, Volume 23, What is Radio? Part 2, Volume 24, How does this apparatus work? Part 3, Volume 25, How does this apparatus work? Continued. Part 4, Volume 26, Why are an aerial and ground used? Part 5, Volume 27, The How and Why of Vacuum Tubes question. Part 6, Volume 28, The Different Types of Amplifiers explained question. A list of links to all the magazines can be found at the end of each issue. Part 2 of 6, How does this apparatus work? Question number 11. What is a panel? Answer. When a radio set is to be constructed, the builder usually prefers to have the various instruments mounted in the most convenient form. He first selects a baseboard, and then at right angles to this, mounts a piece of good electrical insulating material, usually bakelite, which is a material similar in appearance to hard rubber. In this panel, the various holes for mounting the instruments are drilled. Wood may be used for this purpose, but is not as satisfactory as bakelite. Question number 12. What is a tap? Answer. When a coil of wire is wound and it is desired to use various sections of the coil, provision is made so that wires can be attached to certain parts of the coil in order that one or more sections may be used as desired. This process of tapping is shown in the illustration. Figure question number 12, figure question number 13. Question number 13. What is a switch point? Answer. A switch point is somewhat similar to an ordinary machine screw, but has no slot in the head, and the heads are figure question number 14, figure question number 15, usually cylindrical in shape. They are used for connecting taps such as mentioned in the preceding question, so as to make the easiest possible method of varying the number of turns. Question number 14. What is a switch arm? Answer. A standard form of switch arm is illustrated herewith. The switch points mentioned above are placed in a circle or semicircle, and the arm illustrated mounted in the center so that the end of it will make contact with one or another of the switch points as desired. Question number 15. What is a tuning coil, and how is it used? Answer. The usual type of tuning coil consists of many turns of insulated copper wire wound in an even layer on an insulating core or tube. A connection is made at one end of the wire, and another to a slider, which is so arranged as to slide over a path on the coil from which path the insulation has been removed, in order that the slider may make metallic contact with any particular turn crystal detector shown in the illustrations. Question number 16. What is an inductance coil? Answer. The answer to the tuning coil query above will apply here also, as a tuning coil is also an inductance coil. Honeycomb coils and other coils with many layers of wire wound on them would also come under this head. All such coils are said to have a certain amount of inductance, which is dependent on the size of wire and the number of turns, as well as the insulation between the turns. The greater the inductance of a tuning coil, the higher the wavelength to which it will tune. An inductance coil in which the number of turns of wire are not variable is usually tuned by connecting a variable condenser either in series with it or in parallel. These connections are shown in the sketch. When a variable condenser is placed in series with a coil, the natural wavelength of the coil is lowered. When they are connected in parallel, the resulting wavelength is higher than the natural wavelength to which the coil will respond without the use of any condenser. Question number 17. What is a condenser? Answer. A condenser consists of two or more metallic plates separated from each other by an insulating material, which in some cases is air. The metallic plates may have a fixed relation between them, in which case they are termed fixed condensers, or they may be so arranged that their relation to each other may be changed at will. The latter type is known as a variable condenser. These instruments are usually used in conjunction with inductance coils as mentioned above, or in other parts of radio circuits where their use is found advantageous. The unit of measurements of the capacity or value of a condenser is the farad. The capacity of the condensers used in radio work is usually expressed in microfarads, or millionth of a farad. The theory of the action of the condenser will not be dealt with here, as it is very complicated and a knowledge of it is not necessary for the successful operation of a radio set. Question number 18. What is meant by the term coupling? Answer. When an alternating current is flowing through an inductance coil, there is a magnetic field set up around that coil. Any other conductor which happens to be within this field will then have a like current induced into it. This is one of the fundamental laws of electricity. Now in radio work, if we have two coils placed one within the other and an alternating current flowing through one, we will find that a current will be flowing through the other, even though there is no electrical connection between the two. This is known as inductive coupling. If, however, two circuits are joined together by an electrical connections, they are said to be conductively coupled. This is the case in the single circuit tuner as described in the latter part of this book. Continues in volume 25 with, how does this apparatus work? Continued, what is a variometer and how is it used? What is a variocoupler? How does it differ from a variometer and how is it used? Shall I use a loose coupler or a variocoupler for receiving? What is a vernier? What is a rheostat and a potentiometer? What is a grid leak?
Help support ECR by checking out the gift shop. The antenna farm continued from page 23, a short HF antenna. The antenna consists of 3 coils plus a straight run. At the top of the antenna, there's a coil of 67 turns of wire over a 6.75-inch length of the pipe. This is effectively a top loading coil. This is followed by a straight length of wire that is 14.25-inch long. Next is a center loading coil made up of 22 turns of wire over a 2.75-inch length of pipe. Finally, there is a base loading coil consisting of 3 turns of wire over a 32.25-inch length of pipe. At the base of the antenna, that is the lower end of the 3-turn coil, there is an unknown to match the antenna impedance to the 50-ohm coax feed line. To make the antenna, just follow these steps. Drill a hole that will clear the wire you're using about an inch down from the end of the PVC pipe. Pass the wire through this hole and secure it with tape or zip tie. Only pass through enough of the wire to make sure it stays in place. Close-wind the wire around the pipe to form the top loading coil, making 67 turns over a length of pipe that is 6.75 inch. Note, the direction that you wind the wire doesn't matter, but all coils must be wound in the same direction. At the bottom of the coil, use a zip tie to secure the wire. Run the wire straight down the side of the pipe for 14.25 inch, and use a zip tie to secure the wire to the pipe. Some tape will help to keep this wire as straight as possible. Close winding in the same direction as you use for the top coil. Wind 22 turns of wire around the pipe over a length of 2.75 inch to form the center coil and secure it in place with a zip tie. Make the base coil by winding 3 turns in the same direction as the other 2 coils. Spread over a length of 32.25 inch of the pipe. Secure the bottom of the coil to the pipe with a zip tie. You should try to get the turns of this coil spread as evenly as possible over the length of the coil's run. Some tape will help you do this. At this point, you can cover the antenna with duct tape, heat shrink, or other method of your choice. Lastly, connect the unknown to the wire below the base coil. Now you're ready to install the antenna and complete the connections. As mentioned above, this antenna was designed for a 4:1 and that will work flawlessly in situations where your ground and counterpoise systems are perfect. In practice, there is no such thing as a perfect ground or counterpoise system. In the real world, a 9:1 will likely give better results. You can build or buy an un. Retail prices will be in the $50 to $100 range in most cases. On the other hand, you can build an un for about $20 or less. You have to make this call. One caveat for the un you select. Most cheaper commercial un transformers use cheap cores that will not work on 6M, and many won't work on 160M. If you plan to operate on 160M and 6M, make sure that the un you buy or build is rated for those bands. Regardless of your choice for an un, there will be at least 3 terminals you'll need to make connections for. Antenna. This is where the wire at the base of your antenna will connect. It is sometimes marked as wire. Ground. This is where your ground and counterpoise will connect. See below. Transmitter. This is where your coax cable will connect. Different manufacturers will label this in a few different ways, but they will almost all use an SO 239 or BNC connector. The next thing to deal with is mounting the antenna. This antenna, like all verticals, is designed to be ground mounted. In other words, the bottom of the antenna needs to be as close to the ground as possible, never more than about a foot above the ground. Placing the antenna higher than this is guaranteed to make matching all but impossible. In a few of these antennas I have built in the past, I've used a full 10 section of pipe. The top 6 feet are where the antenna itself is built. Then the remaining 4 feet I have put in the ground. This has worked out very well and lets you get the bottom of the antenna within a few inches of the ground. To ensure easy matching, the ground and counterpoise systems must be well thought out and installed. Many times when I have used this antenna, I've combined the mount, ground, and counterpoise all into the same assembly. I drove a minimum of a 4-foot ground rod and used hose clamps to fix the antenna mounting stub to the rod. I then connected the ground terminal from the un to this rod and connected at least 4 counterpoise wires to the ground rod. This ensures that everything is bonded together and will perform well. As for the counterpoise wires, I like to bury my wires about 2 to 3 inches in the dirt. This does 2 things for you. It protects the wires from being hit with a lawnmower or weed eater. Trust me, either case is a mess at best and dangerous at the worst. Yes, this is indeed the voice of experience. It allows you to use non-resonant wire lengths for the counterpoise. In other words, the counterpoise wires can be just about any length you like. In any case, longer counterpoise wires are better, even if buried. There isn't a minimum depth other than the aforementioned need to avoid disasters with the mower, but the wires should not be more than about 6 to 8 inches deep. By the same token, more counterpoise wires are better. In theory, a solid metal plate about 10 feet square would be fantastic. Like anyone is going to actually do that, my rule of thumb is to use at least 4 wires, but again, more is better. Well, up to about 16 wires. In practice, more than 16 wires produces such small changes that it's usually not worth the cost and work. In summary, most of the times when I've used this antenna, I've mounted it to a 4-foot ground rod. So the base is about 6 inches above the ground. Use 8 counterpoise wires, each about 10 feet long, and bury about 3 inches deep. This combination offers surprisingly good performance for such a short, compromised antenna. One last word of caution. No matter how good your ground system, counterpoise system, tuner, and construction technique is, this antenna is a compromised design that is way at the end of the curve. There is no way on earth that this antenna will perform as well as a dipole, end-fed, or a larger vertical antenna. Just not going to happen. But this antenna is small, cheap, easy to hide from nosy neighbors / HOA dictators, and very easy to build and install. It will get you on the air across the entire HF spectrum. If you have extremely tight space considerations or have to deal with restrictions on what you can do in terms of antennas, this is a very good and viable option that I would urge you consider. Next time on the Antenna Farm, we're going to look at something that I've had a few questions via email and on the ECR about: impedance matching transformers. If you know of an antenna construction article on the web, Please drop me a note with the pertinent information, and I will look at it for consideration as an article for the Antenna Farm. Take care in 73. Charles, KC6UFM. The Antenna Farm Archives.
Silent keys. Please keep these people in your prayers and their families to give them the strength, encouragement, comfort, and peace of mind and heart they need.
Thank you for listening to the Reflector Magazine. If you'd like to subscribe, go to bit.ly/ECR subscribe and enter your email. Disclaimer: the content, opinions, and views expressed in this magazine are those of the authors and contributors and do not necessarily reflect the opinions or views of the publisher, editorial team, or affiliated organizations, or anyone else. All articles, images, and information provided are for informational and entertainment purposes only and should not be considered as professional advice. The publisher, ECR, and its volunteers assume no responsibility for errors or omissions in the content provided. Readers are encouraged to verify all information independently. The use of trademarks, logos, and brand names does not imply endorsement. Reproduction or redistribution of any content in this magazine, in whole or in part, without prior written consent from the publisher, is strictly prohibited. For inquiries or permissions, please contact Vicky, ke8vky at ke8vky@gmail.com. Giveaways. Prizes have no cash value and are non-transferable. We cover standard shipping when stated, but are not responsible for lost, delayed, damaged, stolen packages, postal errors, or delivery issues. If excessive shipping costs, fees, or unforeseen expenses arise, we may decline delivery. We are not liable for delays, cancellations, technical issues, emergencies, or any circumstances beyond our control, and participants agree to hold the East Coast Reflector, its volunteers, and affiliates harmless from any loss or damage related to participation or prize acceptance. We reserve the right to modify or cancel the giveaway at any time.